All right, today we're diving into a hidden world of technology that, believe it or not, keeps us safe every single day. It's all about these incredible digital eyes that are out there searching for tiny, invisible dangers long before they can become catastrophic problems.
I mean, seriously, think about it for a second. On a massive bridge, or maybe the wing of an airplane, how in the world do you find a crack that's smaller than a human hair? It sounds completely impossible, right? Well, there's a fascinating field of science that has made it routine, and we're going to see exactly how it all works.
You know, so much of our modern world really does rely on the hidden strength of materials. This image here, it highlights such a critical point. The real integrity is in the weld, in the joint, those places where failure is just not an option. But that strength can be compromised by flaws we just can't see on the surface. And that is where the crucial field of non-destructive testing, or NDT, comes in. You can almost think of it as a superpower for engineers. It's a set of techniques that lets them see inside solid materials to find those hidden flaws and to verify safety, all without leaving a single scratch.
But you know, for the longest time, just finding the flaw was only half the battle. Imagine you found a potential crack using, say, a chemical dye test. Okay, now what? How do you accurately record it? How do you share it with another expert for a second opinion? The old methods, well, they were clumsy and super unreliable.
And this is where technology completely changed the game. The move from chemical photography and old-school physical records to the digital world, that wasn't just some minor upgrade. It was an absolute revolution in quality control and ultimately in safety.
I mean, just look at the difference. It's staggering. In the past, you were dealing with chemical photos that could literally fade over time. They were hard to copy, and you had to physically mail them if you wanted a second opinion. Now, with digital methods, everything's changed. You get a permanent, unfading record that can be copied perfectly and sent to an expert anywhere in the world in seconds. We're talking about the difference between waiting weeks and waiting moments.
But here's something that's absolutely crucial to understand. This isn't just about snapping a picture with your phone. It's a highly controlled scientific process. As the source material points out, it takes careful planning and serious training to turn a digital photograph into a verifiable piece of evidence. So, what does it take to create one of these verifiable images? Let's pop the hood and break down the digital building blocks that inspectors use to create the perfect record of a test.
Okay, everything in the digital world starts with one thing: the pixel. Every single image you see on any screen is really just a grid of tiny dots of color. And for NDT, the more pixels you can pack into an image, and the more information each of those pixels holds, the more detail you can capture. It's that simple.
And that leads us right to resolution, often measured in DPI, or dots per inch. This is all about pixel density. Look, a low-resolution image might be perfectly fine for a social media profile picture, but if you're trying to find a microscopic crack in a pipeline weld, you need an incredibly high resolution to capture every single tiny detail.
This diagram shows a really key technique called resampling. Now, the text is a bit technical, but just focus on the diagram itself. It shows how inspectors can digitally increase or decrease the number of pixels in an image. This lets them optimize the view for their analysis, basically allowing them to zoom in without losing that critical information. The choice of file type is also super critical. For the official record, inspectors have to use what are called lossless formats, like a TIFF file. These files are huge, but they preserve every single pixel of the original data. For just sharing or emailing, they might use a lossy format, like a JPEG, but they would never, ever use that for the primary evidence, because lossy means data has been thrown away to make the file smaller, and that's a massive risk in this field.
But here's where it gets really cool. Capturing the image is just the beginning. The real magic happens when inspectors start processing that image to reveal secrets that were hidden even to the camera. This is where digital imaging turns into an active investigation. It's not just about taking a picture anymore. It's about processing that picture to bring these faint, hidden clues into sharp focus. It's kind of like being a digital detective.
So for example, take a look at these two images. On the left, with low contrast, a potential flaw might just look like a faint, kind of ambiguous line. But by digitally pumping up the contrast, inspectors can make the background darker and the flaw brighter. And just like that, a hint of a problem becomes an unmistakable indication.
And using that same example, another amazing tool is clarity enhancement. Let's focus on the edges of that same flaw. Before, they might be a little soft, a little blurry. But by digitally boosting the clarity, those edges just pop. The indication goes from being vague to absolutely crystal clear. There's no room for doubt left.
Of course, all this power to change an image raises a really critical question. If you can enhance it, can you still trust it? How do we make sure the image stays a true and accurate record?
I mean, this is the million-dollar question, right? If you can change the contrast and the clarity, what's stopping someone from editing out a flaw, or even creating one that isn't really there? The entire system, all of it, depends on trust.
Well, the answer lies in strict, almost forensic-level procedure. First, the original image is evaluated for quality. Second, every single adjustment made is meticulously documented. Third, and this part is absolutely non-negotiable, the original untouched file is archived as a permanent reference. This is not creative photo editing. It's a controlled, scientific process with a verifiable audit trail from start to finish.
So, let's wrap this up by looking at the big picture. Why does this whole leap to digital NDT documentation matter so much in our everyday lives?
What it means is that inspections are now faster and way more accurate. It means a potential problem found in one country can be instantly analyzed by the world's top expert in another. It creates a permanent, verifiable quality record for every single critical part. And ultimately, all of that adds up to one thing: safer planes, safer bridges, and safer power plants for every single one of us.
And that leaves us with a final thought to chew on. We've gone from fading chemical photos to crystal-clear digital records that we can enhance and analyze. Now, with the rise of AI that can spot patterns a human might miss, and with cameras that see in even greater detail, what's next? What new flaws will we be able to find, and what new levels of safety will we be able to achieve? The quest to see the unseen? Well, it is far from over.